Welcome, embedded engineers. This video is part of a tutorial series on developing web dashboards for embedded devices. And in this episode, we will create a simple web dashboard to toggle LEDs on and off. In each episode, we'll use a different development board to demonstrate that the solution works across a wide range of hardware platforms. Today, we'll be using the STM32H5. Plug in your development board to your workstation, connect it to Ethernet, and go to mongoose.ws. Click on the big blue button that takes you to the Mongoose Wizard, a visual dashboard builder. Start a new design from scratch. If you don't see this dialog, then click on the New button on the toolbar. Select Target Directory, where a generated project will be stored. Select Target Architecture, STM32H563, ID CubeIDE, and FreeRTOS. Click Next. Select the blank dashboard. Click Next. Click Finish. Click on Generate Code. Now Wizard has created a cube project with that blank dashboard in the target directory. Let's open it in the CubeIDE. Start CubeIDE, import project, navigate to the target directory. Here is our generated project. All network-related and web UI-related files are in the Mongoose directory. Build the project. Start the serial console to see the logs. Now flash it. Look at the logs to find the board's IP address. Load the IP address in the browser, and here we go. This is the same empty dashboard we saw in the Wizard. This board has 3 built-in LEDs, green, yellow, and red. Let's add a panel with 3 toggle buttons. First, add a container to the page. Then, inside the container, add a panel. Rename the panel to LED Control. Remove unnecessary controls, and duplicate the toggle control 2 times. Change labels to LED 1, LED 2, and LED 3. Click on the first toggle. Notice that it has an API variable setting, and it is marked red, indicating configuration error. This is because control elements like toggles, inputs, drop-downs must be linked to the REST API endpoints, which in turn provide a link to the hardware. Click on the REST API tab. Click on Add API Endpoint. We need an endpoint of type data. Rename the endpoint to LEDs. The first attribute is created automatically. Rename it to LED1. Set type to Boolean and default value to false. Add LED2 and LED3 attributes. Click on the generated glue code to see what code Wizard would generate for that endpoint. As we can see, our endpoint generated a C structure called LEDs with 3 Boolean fields and 2 functions, a getter function and a setter function. The default implementation of the getter and setter uses a mock variable, which simulates 3 LEDs. Mongoose Wizard anticipates us to change the implementation of the getter and setter to attach it to the real hardware. We'll do it later. Now we can link toggle buttons to the new API. Click on the first toggle, change the API variable to LEDs.LED1. Enable autosave. Set references for LED2 and LED3. It is time to integrate our changes to the generated project. Click on the Settings button and change the integration mode to Existing Project. Click on the Generate button. Switch to CubeIDE and build the modified code. And flash it. Now it shows the toggle buttons, which we can change, but these toggle buttons do nothing as they are attached to the default mock variable. Let's create our custom getter and setter functions that are tied to the LEDs and tell Mongoose to use them. Copy over the default implementation of the getter and setter functions from mongoose glue.c into main.c. Rename them to my get LEDs and my set LEDs. Remove the mock variable since we no longer need it. Look at the getter function. When the UI displays the dashboard with toggle buttons, it sends a GET request to the device to retrieve the current state of the toggles. The API endpoint handler receives the request, creates a temporary struct LEDs variable, and calls a getter function to populate it with the current hardware state. So the getter function should read the corresponding LED states and populate the structure. LED1 is pin B0, set data LED1. LED2 is pin F4, and LED3 is pin G4. Now, API handler converts the populated structure to JSON and sends it back to the UI. The UI updates the toggle buttons to reflect the actual LED state. So, for example, all LEDs might be off initially. The setter function works in the opposite direction. For example, the user toggles LED1 to on in the UI. The UI creates a JSON string representing the new LED states. LED1 is on, LED2 and LED3 are off. The UI sends this JSON string to the device as a POST request. Mongoose receives the request, creates a temporary struct LEDs variable, and populates that variable from the received JSON string. Mongoose then calls the setter function, passing the populated structure to it. Now, the setter function writes to the corresponding LED pins. So B0 is set to LED1 value, F4 is set to the LED2 value, and G4 is set to LED3 value. After the setter is called, Mongoose calls a getter to refresh the struct LEDs, converts it to a JSON string, and sends back as a response. The UI gets that response and renders the toggle buttons. In our case, the LED1 toggle will be on. Now, our custom getter and setter functions are ready. Tell Mongoose to use it. Call Mongoose set HTTP handlers function, endpoint name LEDs, getter is myGetLEDs, and setter is mySetLED. Rebuild the project and flash it. Refresh the browser. And now we can toggle the LEDs from the dashboard. Congratulations! This approach can also be used to start and stop motors, enable and disable configuration options, and so on. Hit like and subscribe if you found this useful. Thanks for watching and see you in the next video.